All right. Welcome to our second presentation for object-oriented programming. I am Joshua, and my partner is Nathan. We're going to start out with our PowerPoint. We're going to be talking about some of the things we've been learning over the last couple of units. So we're going to start here with selection statements. These statements are used to execute code in certain ways. The basic idea is that if A is true, then something can happen with B. So some examples from our game. This actually here is from our battle control function, or our battle control class. And so this will generate a random number, and if you can see right up here that if a random number is greater than 14, then it equals true, and you can see that happens right after the curly brace after that statement. Below that, there's another random number for, and we'll make the integer crit for that. So we have the statement if that number is greater than 90, then the variable critical equals true. So if it is greater than 90, then we're able to do something with this next variable that we introduce. But then we also have an else statement saying basically that if critical is not greater than 90, then that variable is false. And so an if-then statement takes care of both of those events that would possibly happen. Here on our next slide, we have our move chance control. And what this one does, it generates a random number, and it will compare it to a couple of different values. The first one here is if the random integer is less than 25, then it's going to go ahead and create a new battle. So then our else if lets us input another set of parameters that we can use to compare our random integer. So with our second set of parameters, if that integer is between 26 and 40 inclusively, then it'll call in a treasure chest scene, and basically the player will get some treasure they can use. And we've also got another else if right below that for a healing pond scene, and then at the very end we've got an else. So with an if-else-if ladder, you can create times where different things can happen based on the number that you get, or on different parameters that you can set. So one of the other selection statements that we use a lot is the switch statement. And this code actually comes from our gender selection view. When a player is creating a player character, they get to choose a gender for the character. So you can see that we have switch choice up here, and choice is a string. So the switch function will compare the choice to each of these cases, and so if it matches either of these, then it will execute the code that's in that case and between the break. If it doesn't match any of those, then it'll go ahead and do what's in the default, which it will just say that it's an invalid selection. So that's basically how selection statements work. So we'll move right along here. Nathan, you still here?
Oh, no, I just saw the screen. Just changed. Okay.
Okay.
I'm going to go over repetition, which is when you have a task that you have to complete that has a lot of repetition to it. Java gives an opportunity to have a function that will loop through and create loops so that you can do multiple repetitions in a small amount of lines of code. And I'm going to talk about a couple of these. The first one, if you see, there's a for loop, and that loop is for when you have a set number that you want to loop through. So if you know how many times you're going to be going through, this type of loop allows you to fix that many times. So if you break it down, you have the first part of the for loop is where we set a 0. We start at the number 0, and we say to do it the next part as less than 5. So we're going to loop through 0 through 4, and then it's going to stop. And then the next part tells I to increment by 1. So every time it goes through, it's going to do the action 5 times. So that's what the for loop does. If you go into the next, below it, you go into the while loops. And there's 2 different distinct while loops. The first while loop, it has it so that if you notice, the while is the beginning of the loop, and what that does is it'll check the condition before it even starts the loop. So if that condition was false, it wouldn't even run the loop. And the difference between these two, like the do while loop, is that the do, it's going to do at least one cycle on this loop, and then it's going to check the condition. And so that's the difference between these 2 while loops. The great thing about while loops is that you aren't constrained by a number. It'll do it until the condition reads false, and then it'll stop. And so that's the 2 different. I've added some code from our game that gives some examples. If you look at next to the for loop, there's an embedded for loop, and what this is when we had our person advance in the map, we wanted to reveal the adjacent locations next to that person as if they can see around them. And doing this would be really, it's a lot of repetition to it to hit all those different locations that are surrounding a person's position. So we created a loop that would cycle through all the 9 different locations and turn it to being visible. And so that's where you can see where it's embedded. It loops through the 3 times 3, so it looks at 9 spots and checks to see if it's something we could create visible. So, and we set it to discover as true if it meets the condition. So, and that's again a fixed loop, so it's going to run that same amount of times every time. The one below, we have a good example of a do while loop where we're going to do something and then we're going to check a condition at the end every time to see if the condition's been met. If it isn't, it's going to loop through again. And this gives an example where we're displaying a tabular menu and it's looking for your input, and if it's looking for really a Q, and I also have a 1, so if it gets a return of a 1 or the user inputs a Q, it'll exit the loop, and this is good for taking data in from a user, and then until he gives you the right answer or gives you what you're looking for. So that's Java repetition.
All right, so now let's talk about arrays. The basic idea behind arrays is that you can store specific information in groups, so it's easy to reference from elsewhere. There are several array functions in our game. The one that we're looking at here is the inventory function, or the inventory array. And what this does is it creates a 2-dimensional array for our inventory. So you can see we start with our create inventory function, and then we name it player inventory, and then we say it's a new inventory, and we bring in some constants as the parameters, and that sets how big this array is going to be, and that will allocate the memory within the game. Here in the next part, we're starting to populate the inventory array. So single-use items inherits from inventory, so we're able to pull that in here, and then we can set all of the different attributes of this particular single-use item, and then we can store all of those in this position of the array. So down at the bottom, when we say player inventory 00 equals potion, we're setting the single-use item that we created up at the top to that position in the array So then later, if we want to reference it, we can just call that position, and it has all of these attributes in there. One of the important things with arrays is being able to sort them and being able to do something for each position in the array when you need to. This sorting function we used for our inventory, and we had to have several for statements so that it would go through each of the first positions of the array and also each of the second positions within that. So we have several variables here. Each of the for statements here will start going through each position in the array, and then the if statement in the middle there will compare the names of the specific inventory items that are in those positions as it's going through each spot of the array. It also checks to see if the quantity is greater than 0, because if they don't have any of that, then we're not going to worry about it for the moment when we're going to print out the list of items. So then down at the bottom, when it says temp equals array1i, it takes the first one that is comparing, if it is alphabetically behind that one, and it'll assign it to temp, and then it'll take the second one that it was comparing and assign it into the first spot, and then it will take the one that was in the first spot but is now in temp and assign it to the second spot. And when it goes through and does this for each individual space in the array, it goes ahead and puts it in alphabetical order for us so that it's easy to find our way around. And so this is a very important function that we can use, and there's also other ways that you can use for loops within arrays. So now we'll move on.
Okay. All right, so I'm going to take on inheritance, and I'm just going to give a brief overview. There's a lot to inheritance, and I'm just going to talk about the basics of it. First, I like to call the terms I use as parent and child. You could also use superclass and like subclasses, but I like the parent-child analogy and thoughts of this. And if you look up in the right corner, I have an example to kind of illustrate this concept. We have an inventory item. This is from our game, and we had several subclasses or children of the parent class, which is the inventory item. And the subclasses or children are potion item, harvested resource, and equipment item. And these three different ones will inherit from the parent, which is the inventory item. So in the inventory item, we have two variables, and those two variables are name and description. And so this is what's common amongst all the children. They all have a name and a description, and this allows that all the children will have that name and description accessible to them, and they all share from the parent. Now, if you look at the children's, they have their own variables and functions as well, and those are all custom to them, and they are different, but they all get to share still what the parent has. And so we get a kind of a hierarchical option here, which gives us the ability to the purpose behind it, which I want to get into, is that one, you don't have to create the code over and over again for, like, we don't have to create the name and description for all of these different item types. We just have to do it once. And if we want to add something to the parent, then they all get that addition, and we don't have to code it for every one of the children. And that's a big time saver. It's smart. It's better to code this way than to have this redundancy. And then also, like I said, the modifications. If we have modifications, they will change if the parents change. They all get that modification. I also have an example in the bottom right-hand corner of our game where we have the inventory, in which we ended up calling gear, and single-use items, which is the potions. And if you look, we have the implementation of this where they're getting the name, the description, and we also added a quantity And if you look at the gear, you're going to have all these specific things to that type of inventory item that it gets in its own subclass or child class. And the other thing that I'd like to quickly overview is that if you have a functions, you're able to also I want to say override the function. So if there's a function in each one, they could all have the same name but do different things. And actually, if we go to the next slide, you go next slide, Joshua. The next slide is going to show you some more specifics, which I'm going to go into interface. But this also shows us an override of the do action. And in the bottom right corner, we had a do action in our views, and all the names are do action, but each type of child has a do action, and they all do something different, but they all have the same name, and that's the override. It allows that way that they can all have the same. We don't have to think of one name. That's where we come into interface. The interface gives us a way that we can display what this program's going to do. It's going to, and this is in our views. We're going to have views are going to do three things. They're going to display something, they're going to get something from the user, and then we're going to do something with that input. And what that does is allows that it forces the game to have that structure, and it allows anybody that's using this program to understand that there's these three things, and they don't have to remember like if we had a different name for every action, then we would have to memorize all these different actions. But by having the do action and having an interface that has these three, we only need to know what do action is, and we know it's going to do it for whatever child is that's working with, and it's going to do whatever child. Like in this case, I give some examples as a get input display from our game, and if you look in the bottom right corner of the do action, we have this these opportunities in this menu that does specific things for this menu that wouldn't be for another menu. So, but they will have the same name and they'll do something specific, and that's the key to interface. That's a brief overview of it, but that's all we have time for right now. Is just to give you an idea of what interface is. I think we're going to go into our game now.
Yes, I'm going to pull up my NetBeans real quick, and we'll be able to show you our game. So I've already got one running. So you can see it has our welcome statement right up here. Can you see this, Nathan?
Yes.
Okay, cool. So we've got our intro to the game right up here, and then it gives us our main menu. So what I'm going to do, I'm going to go ahead and start a new game. And so it wants us to enter a character's name. So that'll be our character's name. And then I'm going to choose a gender. I'm going to say he's male. And then we can choose a class for our character. I'm going to choose the warrior for him, and that will give him more attack and defense, which is helpful. And then it lets us distribute what kind of bonuses we want. So I'm going to put a few in his attack. I'll put about 4 into attack, actually. And then I might need some magic defense, so I'll go ahead and hit F for that. And you can see it displays where our points have gone, and it'll also tell us how many points we have left to distribute. So I've distributed all of my points because we started with 5. So I'm going to go ahead and hit Q, and that'll let us continue forward. And then it'll ask us if this is okay. I'll go ahead and hit Y for yes. And now it's going to put us out in the adventuring menu. So to see where we are, I'm going to hit L, and it'll display our map for us. So you can see that our position is the top left here that's highlighted in yellow. And there's a tree right there, or we're in trees. So I'm going to go ahead and start moving around and see if we run into a battle or something else. Because we have a random function, you won't always run into a battle every single space. And it looks like we ran into a treasure chest first. So go ahead and open that up. And if we look right up here, I guess it didn't load that one. Well, let's just continue on. All right, so now we're in a battle. And so it displays our name, our current health, and our current mana. And then it also shows the enemy, their name and health and their mana. And we have a few different options. If we hit D for defend, then it'll increase our defense by a certain amount. And so it shows that our defense increased, and the enemy attack missed, so we didn't take any damage anyways, but that's always nice. So we're going to go ahead and try attacking him and see if we can defeat him. So we did 5 damage to the enemy, and you can see that reflected in his health that's displayed. And he missed again, which is nice for us. So we did another 5 damage, and we were able to defeat him. And we gained 23 gold and 15 experience points. And so those were added to our, player gold and our experience points pool. If we gain enough experience points while we're here, then we might level up as well. All right, let's go ahead and fight this guy. And we went ahead and defeated him and got another 15 points. So let's go ahead and walk around a little bit more. Now in this battle I took 2 damage, so my current health dropped to 48, and that should show up in our next battle that we start. Yep, it's still 48 there. So we can fight him a little bit more. Oh, and I must have gotten a critical hit, did 10 damage to him and killed him in 1 hit, which is pretty cool. Alright, let's go ahead and attack him. Wow, another critical hit. That's something, actually. Found a treasure chest. I'll hit O and open it up. Alright, we didn't quite load that one either. I was messing with the code a little bit before we did the presentation, so maybe I messed with that a little. Alright. Did 5 damage, enemy attack missed, defeated him. We can do a couple bit more battles. The game isn't entirely finished yet. So there's still a few functions that we want to implement. Here we go. You found a greater potion. I was working with the array a little bit, and so I might be pulling up a couple of blanks in there. I'll have to go in and change that after this. Alright, let's go ahead and attack him. Did 5 damage. So, since we gained enough experience points, we gained a level, and we get another 5 points that we can distribute anywhere that we want. So I might do some more attack, and some more maybe magic attack, see if that does anything for me. And maybe some more health points. And then once I've spent all my points, I can hit Q, and it takes me back out to the map. So that's basically our game at the moment. We're going to be implementing more stuff in the future, but we hope that you enjoyed seeing that. You want to add anything, Nathan?
No, I think everything's great.
All right. Well, thank you for watching, and that's the end of our presentation.
Great.